This is a message for Phil Lassner. Please turn your webcam on. Oh, you did. Perfect.
I read your mind.
So Phil, if it's okay with you, I will forward the slides in your presentation. Is that okay? Or did you have a presentation that I don't have?
No, I actually I have an updated one. If you don't mind, am I allowed to present it?
Yeah, you can. I can make it presenter. Yep.
Okay, great. Unfortunately, Ian's not going to be able to make it this evening, so I'll be filling in for him as well.
Perfect. Thank you.
We got 5 minutes more to go. 8:30.
Yeah, we'll start maybe at sort of 8:33, like what we did last night. Sorry, 8:33 a.m. your time. Just to let attendees in. Yep.
Janica, may I know whether Mr. Ian Steele, CEO Canada, is in already?
Ian will be joining the session. He will be providing some opening remarks.
Okay.
I haven't. Oh, there he is. Yeah, Ian is present. You can see him under staff. Ian Steele. He is there.
Good evening. How are you?
Ian. Good. How are you doing?
Good.
Good. Ian, would you like? Oh, there's your webcam. Perfect. Beautiful. Thank you. Here's some nice chirping. Okay.
We are still waiting people for joining, right?
Yes, people tend to, how shall I say, they come in, just like last night where we started a little bit later, and then as the webinar goes on, people will come.
Okay, all right, yeah. So you just give me the signal to start when it's ready.
Okay.
Okay, thank you, thank you.
You're welcome. Mr. Ismail Saleh, you are president of ITS. You are president of ITS Malaysia, correct?
Right. President, yeah.
So, yeah. May I introduce you to Ian Steele, who is the chairman and CEO of ITS Canada. I know that this is it's informal, but I would like to take the opportunity before we start just to.
Mr. Philip or Ian Steele? Oh, Ian Steele, yeah. Hi, morning. Morning.
Yeah. Very nice to meet you.
Okay, nice to meet you. It's a very strange way. So ITS Canada, you have your own setup, eh? You got your CEO, you got the MD. Wow, quite a big setup, man.
Yeah, yeah. Yeah, no, we're a pretty comprehensive organization, actually. And Janica is our managing director and looks after all of our internal affairs and keeps everything running.
How many staff you have running in the office? Any idea? Only one man show. Okay.
Yeah, we have, of course, a board of directors. There's 16 board of directors. They're all volunteers. We have a number of tech committees that, much like you, I'm sure they're all volunteers. So we have quite a large roster of volunteer support for the organization. But officially on the payroll, we have just one person.
Okay. You are not seconded from any company, organization, or you are fully employed full time then?
That's correct. Yeah, no, I have a day job, and I have another. I'm a consultant. I work for a consulting firm, and our benefit is that Yannicka, although she is one person on paper, she does the work of about 4.5 people. So we're in the beneficiary position of her being able to do much more than a single person is capable of performing.
Yeah. Because I know every time World ITS in the world, Canada presence is very big, very big pavilion. A lot of people inside there from all over your district or your country. But lot support from all over the Canada, right?
Yeah. Thank you. Yeah, I agree with that. I think we punch above our weight in terms of the number of people involved.
Okay, Sullivan, can you turn your webcam on, please? He's one of the panelists. We would like to. There you go. Perfect. Hi. We can hear you.
Sorry about that. Good evening.
That's
Good
fine.
morning.
We just wanted to make sure that we have all the panelists and everybody
Online.
online. Yeah, so I think we're just waiting for Emmanuel from Invision AI to join. I know that he's in France. So I think we may have some flexibility that if he shows up a little bit late, that Philip would go first if Emmanuel shows up late. So maybe some flexibility there, if that is okay. Okay, I think in 1 minute we, Dr. Leung, we will start at 8:34. So 2 minutes. We will kick off day 2 of our webinar series.
Okay, so very likely Mr. Philip will be the first one then. Am I right?
If Emmanuel is delayed and I don't see him yet, then we might start with Philip, and then see once if we have to do it that way, just to keep the flow going. The last time that ITS Canada hosted a webinar and we had many speakers, so not last night, I actually took my phone and took a picture of everybody on the webcam, but apparently there's right on top of my screen something called screenshot. So I know, learn as I go. The screenshot of all speakers anyway. So I saw that last night. Wonderful. So, Dr. Leung, it's my honor to introduce Dr. Leung as tonight's moderator. Over to you.
Right. Thank you very much. Thank you very much, Janica. Good day to all the honored guests, speakers, participants from our ITS fraternities, from ITS Korea, ITS China, ITS Taiwan, ITS Indonesia, and the other Asia Pacific ITS institutions. My name is Leung Siu-man. I will be the moderator for today's session. And today's session is a bit challenging as we are going to have 2 opening address by the CEO of ITS Canada and also the President of ITS Malaysia, who have jointly organized this webinar with the team ITS Build Back Better, as well as 5 technical papers presentation. I welcome all of you to this webinar, and to be fair to our Canadian organizers, so that they won't be dragged into middle of the night, and giving equal opportunity for all the speakers to have the time for presentation, I urge every speaker to strictly observe the time duration given to you. My apology if I may have to cut you off abruptly if your speaking goes beyond the time limit. I have dedicated a special time slot after all the presentations for an Q&A session, and you can submit all your questions through the chat box and preferably identify who you are and whom your question is directed to. Without further ado, I have the pleasure to invite Mr. Ian Steele, CEO of ITS Canada, to have his session opening address. Over to you, Mr. Ian.
Dr. Young, thank you very much. It's very nice to meet you all and see you in this virtual format. Many people I've never seen and met before, so very happy to connect. Good morning and good evening, everyone. On behalf of ITS Canada, our board, our members, welcome to this joint webinar. We're very pleased to be involved. This webinar's topic area, I'm sure, is front of mind for all of us. I know at ITS Canada, as an organization, we were weeks away from releasing our new strategic plan in early 2020 when the pandemic hit. So we pushed pause, we regrouped, we reflected on how the new reality was affecting our transportation system before releasing our new strategic plan in late 2020. And of course, even since then, much has changed and much has been learned. Our members are actively engaged in understanding and addressing this massive shift in and impact to our national transportation network. And we're very happy to be here today to share our members' experience and to learn from yours. I think if there is a silver lining in what's happened in the last year and a half, it's that these virtual events are that much more easy to organize. And we've had the opportunity to connect with yourselves and other colleagues across the world on a more regular basis, and really welcome this opportunity to share our experience and our expertise, and again, learn from yours. So with that, and in respect of Dr. Lung's time commitments and notification there about staying on schedule, I'll keep it brief. But thanks to everyone who was involved in organizing this event. Even though they are virtual, they still take a lot of time to put together. So thank you to everyone who contributed. And thanks to everyone who made time this evening and this morning to be a part of it. Without your input and involvement, it would really be a much more pale reflection of the event. So thank you again. I hope everyone enjoys the content. It looks like it's an excellent roster of engaging presentations, and welcome and enjoy the show.
Okay, thank you, Mr. Ian Steele, for your welcoming remarks. Next, I would like to invite the President of ITS Malaysia to have his session opening address. Dr. President, the floor is yours.
Thank you, Dr. Leong. ITS Malaysia is very happy to welcome and to work together with ITS Canada. So we like to thank the council member, would like to thank all of us, all of you all, able to attend day 2 of the joint ITS Malaysia and ITS Canada. It's the first time we do, and the team is very strange, build better, back better. So we have to beat the previous. We have something. We have to beat something back. So I hope we are not backtrack, right? So it's something new challenges. ITS Canada is a very strong supporter of ITS Malaysia since the founding days, actually. Of course, those days we only know the Lam who connect us with the ITS Canada. So every time we go to the INI conference, World Congress, I remember 2017 in Montreal, a big group from Malaysia, around 30 even, and also my Minister of Works also there. So we enjoy every minute in Montreal's conference, very fruitful. We able to visit Highway 407. We go to Toronto. We got many things to see. Of course, we never forget the Menara Fort. And that is the best highlight of the conference. Even though Canada is long, the opposite part of the world. We are 24 hours different maybe. Now, sorry, you have to wake up now at night to watch this webinar to accommodate us, because we are at 8 o'clock here, 8:30 start work. You're supposed to go back to work in the bed on the. Okay, so we appreciate this webinar is held. We can discuss both issues, even though we cannot have a physical meeting and so on. Webinar will connect us. So to me, this is not the I hope we able to collaborate more things, because in Malaysia, ITS Malaysia, even though we are set up quite some time, So the ITS deployment is quite a bit low actually. So even though, but the past 2 years, the government have already introduced 2 major master policy actually, before the pandemic actually. So of course, ITS Malaysia give some input to the government, where they develop the what called national transport policy, and also the other one is automobile policy. These are two big policy. And also yesterday we remember we heard about the blueprint presented by the Ministry of Works, and that is a subset of the policy. So we hope with this policy actually the government will be able to move accordingly in more systematic way. So of course, it's always a challenging to have ITS working in any part of the world. I think yesterday our friend from consultant Mohd McDonald mentioned that the challenges about the big data, collecting of data is also very challenging to do any project. I don't know in Malaysia, but I believe in any part of the world. So be collecting the data to do a certain project is a very big thing. Integrating the system. Sometimes in our area, there are so many people do ITS application, but sometimes they don't work, they don't communicate each other. So we got very segmental system. So the challenge is how to integrate all the system so that they can benefit the user, and also not to waste money and so on. So interagency coordination is also very challenging in Malaysia.
Sorry, Mr. President, time is already running out.
Yeah, okay. So these are the challenges and so on. So we hope we can work together with ITS. We are very pray. Hopefully, with the pandemic is over, so we'll be able to travel to Vancouver to see some of the ITS application there, and of course we can meet there and discuss more detail. So I'd like to thank everybody. I am still the CEO of the ITS Canada. We hope we can meet more often through webinar or other discussion, and for the benefit of the ITS, and also for in the way we hope the private sector to come in and so on. Thank you very much to all the speakers who are able to give their presentation today. Thank you, Dr. Leong.
Okay, thank you, Mr. President of ITS Malaysia. My apology for interrupting you. I do not know whether Emmanuel is already on board. If not, we may have to get Philip to speak.
Yes, he has joined.
He has joined? Okay, good. Now we will move on to our first presentation from Mr. Emmanuel Corday, representing Invision AI. Mr. Emmanuel Corday is the Vice President Products Division of Invision AI. He drives the development of Invision AI's platform that leverages artificial intelligence and computer vision to provide analytics and safety solutions for routes, public spaces, and real environment. He has more than 15 years of experience in launching innovative products to the market and has led many R&D teams, such as Swisscom in Switzerland, as well as CGI in Canada, where he has successfully delivered a promising system for IP communications and launched a unified communication managed cloud services at Allstream. Over to you, Mr. Emmanuel.
Yes,
Emmanuel,
good.
it's Yannick here. Do you want to present your own slides?
Sure, I guess you said you would, but I can do that. Let me know what you prefer.
You present it?
Sure. Up. Let me know when you can see my screen.
We can. Thank you.
Yes, yes.
Okay, very good. So, good afternoon or good morning, depending on where you are. Thank you for the introduction. And I'm very happy to be able to share a little bit of what we're doing at Invision, and hopefully give you a sense of what is possible today, some of the leading edge applications that we're working on. And also I want to show some examples. Hopefully I'll leave it enough time for some of the demo videos of some of the project we've been working on. And yeah, I'll be happy to also answer any questions that you may have. I'm going to try and stay on time. So please let me know if that's not the case, but it should be good. So what we're doing at Invision is we're really working on how you manage the amount of data that is generated by sensors whether that's, you know, in the ITS situation, something that is in the car, whether it's a camera that is on the road or in a city, or anything like that that you may have. Obviously, there's more and more sensors out there, more and more data generated. And basically, the approach that we took when we were founded about 4 years ago is that it's too much data to send everything to the cloud and be able to compute and get insight out of this data out of the cloud. So what we focused on is how to manage this data and treat this data at the edge, meaning close to where the data is produced, meaning in the case of a road, by the side of the road, or if it's something for smart cities, let's say, right where the cameras or LiDAR or radar data is generated. Because what we specialize on is the vision side, thus the name Invision, right? So what we've seen is when you have too much data, you can't really do it there. You have to do it at the edge. The second reason and third reason for that is if you have a safety critical application, let's say you need to detect that there's an accident in an intersection, or you have a problem on the road, you need to be able to detect that very quickly, you know, in a few milliseconds, maybe alert vehicles in that intersections. In the case of a train, because we're also working with train, you need to alert the operator. Maybe you have, let's say, a stuck car in an intersection. Then, you know, for this reason, you also need to be very fast. The third reason is that for privacy reason, if you have multiple cameras sending streams to the cloud and somebody is able to intercept that data, that might not be good from a privacy point of view. There is more and more issues, as we've seen, and awareness of privacy. So what we're able to do is we're able to use camera data, for example, live camera data, and treat it right there where the camera is, you know, within a few meters of where the camera is. We have a few, you know, embedded computers or systems that is treating this live stream, and that way we don't need to send all of this data to the cloud, right? It's also very important not to have too much data sent to the cloud because you might have bandwidth issue. You know, imagine you have roads and you have a camera every few you know, meters. That would be a lot of bandwidth to send all of this data to the cloud. Whereas with our system, we're able to have a few cameras at an intersection, let's say, and we have a computer there that is treating this. And we only send the data to the cloud that we need, meaning what we detect, right? So that's key. So at the edge on the left, that's where our, let's say, edge computer resides with the cameras or radar. We're able to do detections of things. Mostly it's people, car, hazards on the road, like an animal, maybe a car that is backing up on a highway. We're able to detect these things as well. And in the case of a moving train, we're also able to detect where the road is, you know, elements of the picture or the view. And we're doing that at the edge and only sending to the cloud what we detect, right? So the applications that we have, I'm going to dive right into them. Smart cities, autonomous rail, and smart roads. That's what you're interested in, obviously. The first one that I'm going to talk about actually at the end is the most mature one that we have. It's an occupancy detection system. So here we put a unit on the side of the road. It's mostly a highway. We have quite a few of those highways in Canada that have a high occupancy lane. So it's a special lane on the highway where people that have more than one person in the car either pay less or pay nothing. And so we're starting to see more and more people, or actually government mostly, doing this to basically promote smart mobility and promote carpooling, for example. And so they will have a lane specialized for high occupancy vehicles, and people in this lane will either, you know, not pay or pay a fine if there is only one person in the lane. What we see happening though, and that might be some idea for your areas of the world as well, is dynamic tolling. So instead of saying the HOV lane the high occupancy lane is only for people that have more than one person in the car. And if you have more than one person, we'll send you a fine, and you'll have to pay because you broke the law. What is starting to happen is you have a lane like that, and if you have more than one person on board, you don't pay anything. But if you have only one person on board, you pay a fee, right? So it's kind of a toll, but it's a dynamic toll that it only applies when you have only one person on board. So it starts to be really important and interesting to be able to detect people inside the car without having a person there, or in case of enforcement, without having the police on the side of the road trying to see how many people are in the car. So we have a solution there. I'll show you some high-level videos where you put a side unit on the road, and it's able to automatically count people in the car fully automatically and without having to send pictures to somebody. So that preserves privacy as well. The second application, and I hope that you see the little video here in the screen, is for smart intersections. So what we do here, and you'll see the little box around the cars, is we're able to take a camera at an intersection and not only detect that there are cars, but also detect in space where the car is. So you see on the map on the top right here, we have the top view of the intersection, and we put on that top view the little box here of the car that we detect. And not only the car, but also the volume taken by the car. So that's starting to be able to tell us exactly where the vehicles are, the size of the vehicle, whether it's a car, whether it's a bike, whether it's a bus. And that gives us a lot of interesting information. Obviously, there's statistics information about the use of the road, but there's also information about danger and behaviors are bad and things like that. Another application would be for rail, where you have an intersection with a railway crossing and you see the car here. We're able to basically pinpoint where the cars are, and if there's a conflict with the railroad tracks, then we're able to alert the train, for example. Last application is on a train, so we're able to detect people. And again, on the little map at the top right, you see that we actually put on the map what we detect. And so we're able to basically compute where the car or the pedestrian is with respect to the train, and if there is going to be a conflict with the rail, right? So that's dynamic. We're able to detect where the road is, where the tracks are, where the cars are. You see them on the little map. And what we're doing here is a trial right now in Toronto on one train, and we can alert the operators, or in this case, compute statistics about what's happening. Wanted to show you another demo of another project that we have here. And what we're doing here is the same idea, but we're also adding distance between people, right? So you're seeing that here we have two cameras, the top left and bottom left, and we're detecting people, and distance is shown on the map in either green when there is enough distance between people, or yellow, orange, or red when there is not enough distance between people. So we're able to compute the distance between people, and we're able to display trajectory here on the right on the map. And that gives us then statistics about where are people coming from. So what this city was interested in is to know where people are coming from for an event, and that helps them determine which event drives people, where they're coming from, and also information about safe distance between people. We're also working on adding detection of face mask, for example. So that's great for public safety. And we're also detecting hazards in the future, like fire and things like that. That's a top view of the interface we're working on. So that gives us a heat map of where people are in that area, and developing the user interface. Just wanted to show you a little example. Almost there. So the roadside unit, that's the first prototype. Now we have smaller versions, but basically it looks like that. It's taking basically a few views when we detect a vehicle. We have some infrared panels to help illuminate the people in the car. And the way it works, I just showed you, I'm gonna show you this animation here, is we have a little LiDAR that detects the cars. We have IR and cameras. And basically, hopefully you see this little animation. The cars pass through, they're illuminated by the infrared. We take some pictures, And that way we're able to count people using artificial intelligence and computer vision. And we send statistics to the operator, number of vehicle per day, number of people per vehicle. And we're also doing license plate recognition. That's not our product, but we combine it with ours and send all of this information in real time to the operator of the road, for example. So that's the last example. Yeah, so just a little summary. We're leveraging artificial intelligence and computer vision.
You have only 1 minute left.
Yeah, that's my last slide. Thank you. So we're leveraging AI. We're having the ability to use multiple cameras and combine different views to have a really good understanding of an area based on cameras, LiDAR or radar. We're able to reuse cameras in most cases, or for the multiple occupancy vehicle, it's in some cases specialized hardware, because that's, we have to make sure we have the infrared to see inside the vehicle. We're doing it at the edge. We can work with cellular connectivity, preserving privacy, and we're enabling green mobility, safer cities, and providing strong and very advanced analytics, basically. And that's it. Thank you very much.
All right. Thank you, Mr. Emmanuel, for your very interesting product. And perhaps maybe I personally are interested. I may want to contact you for more information. Thank you very much.
No
the
problem.
second paper now will be presented by two gentlemen, Mr. Philip Laser and Mr. Ian Boy from Bluecity Technology AI. Philip is a CRO at Bluecity and responsible for growth strategy and its execution, while Ian Boy is a co-founder of Bluecity and is currently holding a master candidate in transport engineering at Macquarie University. He holds a bachelor's in engineering and is currently focused on the development of Bluecity's AI perception layer, as well as a safety analytics platform. Over to you, Mr. Philip, and I hope you can stay on with the time limit. The floor is yours, Mr. Philip.
Thank you very much. Unfortunately, Ian won't be able to join us today, so it'll just be me. So okay. Yes, correct. Thank you very much. My name is Philip Lasser. I'm Chief Revenue Officer.
Phil,
yeah.
It's Janica here. We can see two screens, one that includes your notes. So you probably want to remove the your notes screen. At least that's what I'm seeing.
Oh, okay. I don't know how to do that.
So be able, do you have two screens in front of you?
Yeah.
Yeah.
Okay. Okay. So I'll just go from here. Okay. So, yep. My name is Philip Lasser.
But now we can't see anything. We can't see any slides.
Interesting. Okay.
Philip, try opening it again and then just hit switch presentation screens.
Correct.
Is that better?
That's it.
Oh,
yes.
Great. Thank you so much. Okay, so no problem. Let me just go back a slide. Okay, so my name is Philip Lasser. I'm CRO of Bluecity. I'm responsible for global growth. I'd just like to say thank you to Janica and Joe for inviting us here from ITS Canada. ITS Malaysia, thank you for co-hosting this event. I look forward to meeting you and working with you in the future. And to all the viewers, I look forward to hopefully meeting you someday. And if you want, please get in touch with me if you have any further questions. Okay, so the problem we are trying to solve, we think cities rely on a mix of imperfect technology as the backbone of transportation data. And they rely on this data for traffic operation, road planning, and safety improvements. The technologies included seem to be inductive loops, radar, and cameras in their ecosystem. Still, the majority of intersections are monitored by inductive loops. Sets of wires typically goes below the pavement and mainly provide data about presence of cars, but those are expensive to implement, require road closures and wiring for each lane to the traffic controller, and are extremely expensive to maintain. As an alternative, radar-based solutions are used as non-intrusive technologies, but still one intersection requires 4 of them, 1 per approach. Similar to loops, radars mainly provide detection and counting data about cars and not other types of road users. For this reason, the usage of this technology is mainly limited to traffic operation. It's good for 24/7 data in any weather and lighting conditions, but bad for multimodal data. So now, to collect data for traffic planning and safety improvements, cities should add cameras to be able to classify different types of road users, including pedestrians, cyclists. But cameras fail to perform under extreme lighting conditions, either low lighting and rain and snow, where more than 70% of road accidents are happening in these scenarios. That is why the usage of cameras are mainly limited to traffic studies, and always with cameras, there are some privacy concerns. Our company has built a turnkey solution that addresses cities' data need for traffic operation, road planning, and road safety, all with a single sensor technology. So what's Bluecity's solution? Bluecity developed a unique and proprietary AI app perception layer, which turns raw LiDAR data into valuable traffic data and analytics. This layer sits on an edge processor, which is typically installed at an intersection. The edge box is connected to a LiDAR sensor, a traffic controller, our visualization platform, and if requested, connect to third-party applications and peripherals using our APIs. Go to the next slide. Our solution works in all weather and lighting conditions. It's multimodal, providing data into non-vulnerable and vulnerable road users. It's cost efficient. Typically, 1 sensor is required per installation, installed usually on the same pole as a traffic light controller. It's completely privacy safe since we're using a laser to measure absolute distance to object. We do not capture facial data or license plate data. And perhaps most impressive is our enhanced safety analytics platform, which we will demonstrate a portion of today. So how does it work? LiDAR stands for light detection and ranging. By shooting out lasers millions of times per second and measuring the distance to where they hit the LiDAR makes a 3D representation of the intersection and the vehicles, pedestrians, and cyclists that are in the intersection. We chose to use LiDAR as the lasers are their own light source. So our sensors can work whether there is sun is directly in view or if there is no external light source at all. Additionally, the wavelength of the light emitted by the LiDAR we use lets us see in virtually any weather condition. However, unlike with cameras, LiDAR on its own can't count, track, or identify road users. For that, Bluecity's perception software is needed. Bluecity uses neural networks that detect, locate, and classify the road users in view of the LiDAR. The neural network is taught to do this by looking at thousands of frames of hand-labeled LiDAR data from dozens of intersections. This huge and growing data set ensures that our software performs well as soon as the sensor is installed, even in new situations. From the detections, our software tracks each road user as they pass through the intersection. On top of these tracks, we have built many applications. We can connect to the traffic light controller and provide presence detection, simulating inductive loops. We provide 24/7 turning movement counts and on-demand traffic studies. We can provide signal performance measures. Finally, we perform safety analysis such as post-encroachment time, looking for situations where close calls are common. All of these applications are available with one sensor at the corner of the intersection. So today's sample use case we're going to dive into is our proactive approach on safety. Let us first understand the current state. The safety of intersections, interchanges, and other traffic facilities is most often assessed by tracking and analyzing police-reported motor vehicle accidents over time. Given the infrequent and random nature of accidents, this process is slow to reveal the need for remediation of either the roadway design or flow control strategy. Surrogate safety measures instead studies the movements of trajectories of road users to proactively identify the potential accident risks. Our conflict analysis uses artificial intelligence to perceive and estimate post-encroachment time, or PET. PET represents the time difference between a vehicle leaving the area of encroachment and a conflicting vehicle entering the same area. PET is a factor that is used as a measure of conflict. It is highly correlated to the risk of accidents. PET values, typically less than 2 seconds, are classified as critical conflicts, and from 2 to 4 seconds as unsafe conflicts.
This slide is a screenshot of our online interactive heat map, which visualizes.
You have only 1 minute left.
Okay, which visualizes conflict data. The user can filter the types of road users, filter the type of turning movements, and filter PET value. Once the filters are adjusted to the user specification, the associated conflicts on the map are represented, and the user can see a video, as you can see here on the left. We are ready for the future. With 5G connectivity and edge computing and open APIs, Bluecity has low latency, reliability, and flexibility for future and safe applications. I'll wrap it up there. Thank you again for the opportunity to present. Feel free to contact me if you have any further questions. Thank you.
Thank you. Thank you. Thank you, Philip. I'm so sorry to rush you off. It's a very interesting paper, and I will follow up with you on more information on your product. Thank you very much. Thank
Appreciate it. Thank you.
Thank you. The third paper on the line is by Mr. Muhammad Shahrulnizam Sarip from Malaysian Institute of Automotive, Robotics and Internet of Things, or MARI. He is qualified as EE and System Engineer from Saitama University, Japan, and MSc in Engineering from University Putra, Malaysia. He is currently the Chief Technology Officer at MARI, with specialization in the area of vehicle construction, standards and regulation, testing, road vehicle acts and policy, as well as e-mobility development for connected mobility ecosystem. He is one of our ITS Malaysia Council member and represents Malaysia as automotive expert in ASEAN Consultative Committee for Standards Quality, International Standard Organization, as well as in the World Forum for Harmonization of Vehicle Registration Regulation. He will be presenting to us e-mobility developments in Malaysia. Over to you, Engineer Muhammad Shahrulnizam. Please restrict your presentation to the time limit. Thank you.
Good morning, good evening, everyone. As introduced, I'm Shahrulnizam. Will be presenting on the e-mobility development in Malaysia. Next slides. Could you please move to the next slides? Okay. As introduction, I'm from MARI, which is an agency, government agency under Ministry of International Trade Industry, and we are assisting MARI to formulate the national automotive policy and ensure the full implementation of this NAP. Apart from that, I'm also the council member for ITS Malaysia. I believe we have most of our council member today, which is an non-government organization which is responsible to focus and fostering the multidisciplinary partnership and activities with regards to the ITS technologies. Next. To start with, I'm going to share with you on the snapshot of Malaysia automotive industry. Due to the COVID and also the pandemic situation, of course, the total production volume and total industry volume was reduced around 12 to 13%. And however, we are still managed to cope with the automotive industry development with the assistance coming from Malaysia government by giving the tax exemption, sales tax exemption. So for that reason, we have successfully achieved more than 500,000 sales in Malaysia and attracted more than 9.7 localization activities. So as said now, more than 88.3% energy efficient vehicles have been penetrating the Malaysian market. So to ensure the continuous expansion of the automotive programs in Malaysia, we have introduced several elements which include the development of next generation vehicles, the embedded solution via the Industry 4.0 technologies, as well as to introduce the mobility as a service into the mobility sector. Next. As mentioned by our Datuk Sri President ITSM Malaysia, so there are few policies that is closely related with the ITS development. The first policy is the National Transportation Policy. This is under the supervision of Ministry of Transport, and MARI also have been tasked to ensure the success of this policy, especially in the area to expand the global footprint by promoting the electric vehicle development as well as the low carbon mobility blueprint. Okay, next. As shared by our representative by Ministry of Works Malaysia, so this is the overview of Malaysia ITS Blueprint covering the 9 ITS sectors, and this ITS sector actually aims to link the 4 different stakeholders coming from roadsiders, vehicle travelers, and also the centers. So under the ITS Malaysia Blueprint, we have underlined more than 36 initiatives or user services, and it will be deployed based on separate ministries, and all development will be monitored by Ministry of Works. Next. As for the National Automotive Policy, this is the policy under my supervision. So we have introduced the 3 elements that I mentioned before, and most important elements include the next generation vehicle, which aims to integrate the electric vehicle powertrain system with the autonomous vehicle function. So by leveraging on the user services as the spin-off of the NHJV, it also will be complementing the National Transportation Policy to transpose the car ownership to the mobility as a service. So mobility as a service actually is a concept that is integrating various types of mode of transports, and to ensure that the automotive sector can be shifted into the connected mobility ecosystem by year 2030. Next. Next slide. Okay. Apart from that, to make sure that we are aligning with the whole connected mobility ecosystem in Malaysia, we also have adopted the ISO 37122 to give the certification on the identified area, or will be classified as the smart city. So there are 39 indicators has been introduced under these national documents, covering with several indicators, and the transportation also become one of the important element in order to be classified as smart city. So this is covering the percentage of the streets that is utilized with the ITS technologies, the percentage of the integrated public parking with the centers, and etc. Next. From now on, I'm going to explain a little bit on the actual deployment activities and also the concept of the next generation vehicle that have been introduced in Malaysia. Next. So this is what we have envisioned by year 2020 that to be deployed in Malaysia, which is the next generation vehicle will be communicating with the whole ecosystem to improve the operation, which include the sensing, cognition, and also decision and action. So the vehicles is expected to be communicated with the infrastructure, with the environment, with the surroundings, and with everything. Next. What have we defined for NHGV? We have gazetted the Malaysia Standards 2730, the next generation vehicle standards, which is actually the adoption of SEJ 3016 and also the World Forum for Harmonization of Vehicle Regulation WP29 guideline into our Malaysia standards. So in the National Automotive Policy, the energy efficient vehicle technology will be further enhanced towards the NSGV, which is defined as EV powertrain and meeting at least level 3 of this autonomous level. So from the level 3 onwards, it will be the intervention of the driver is very minimal for the level 3, and from level 4 onwards will be the fully autonomous vehicles. Okay, next. So this is the key technology development that we are focusing in Malaysia, which consists of the autonomous vehicle platform, the future sensor fusion solution, the data storage and computing, and also the testing and validation. Next. So to kick off with this technology, we start with the telematics or the onboard diagnosis, which become the communication port for vehicle to be communicating with the surroundings, with the infrastructure, and with the environment. So the telematics consists of the three independent breakthrough of the modern technology, which include the internet, the global positioning system, and also the mission-to-mission communication. So this technology is widely used by the transportation to deliver businesses, and also that send out the large fleets, vehicle, and products. So apart from the tracking of the vehicles, the telematics technology also be used for monitoring of the complete fleets of vehicles and driving behavior from speeding, idling, fuel usage, and etc. Next. So what we have done in Malaysia is that we get the primary data from the vehicles, we deploy the pilot projects, and then we process the data. We compute it and visualize in the area of in the form of dashboard, and then we use it as the development and reporting to the authorities. Next. So I'm going to share the current development status for the electromobility ecosystem improvement in Malaysia. Next. So to attract more investment in the next generation vehicles, the Industry 4.0, and also the development of mobility as a service, government giving the full exemption for the import and excise duty for electric vehicles and also hybrid car. This is to promote the powertrain ecosystem development. And for those investment that is related with the intelligent transportation system and the development of mobility as a service, we're also giving the corporate tax exemption up to 10 years, depending on what type of activities that is being done by particular companies. Next. So apart from that, we also harmonizing our Malaysia standards development, our domestic regulations by adopting the United Nations regulations into our legislation, adopting the ISO standards into our legislation, and to make sure the industry will be developing the products in line with all these standards and also regulations. So this includes the requirement for the powertrain system, especially in terms of electric vehicles, battery testing, and etc. Next. So I said now, for the electric vehicle registration, we have recorded around 3,000 vehicles for year 2021, and for hybrid, it was recorded more than 45,000 units. So we have deployed a lot of electric vehicle pilot projects. We include the R&D projects under MARI, the deployment in the certain local authorities area, for example, in Putrajaya, Melaka, and also the leasing projects has been launched since year 2014, and this will be expanded in year 2020-21 to make sure that the sharing concept and also the leasing mechanism, and to ensure the deployment of mobility as a service can be realized. Next. So this is the record of the charging station that is currently available in Malaysia. We have recorded more than 326 public EV chargers station, and currently it was recorded more than 180,000 charging station was be leveraged using these public chargers, and also it is estimated more than 1 kilogram CO2 emission have been avoided. As for the telematics project that become the communication port for vehicles in Malaysia, under MARI we have deployed more than 1,000 vehicles to collect the data in terms of routes, and we have aggregate the data in terms of which area has been be more in terms of the speeding alerts, harsh cornering, and also harsh braking. And we have compiled the data and give the input to the authorities to formulate better policies. Next. And we also have allowed the autonomous vehicle mixed traffic testing. This is under the Ministry of Transport guideline with the assistance from Futurize. And so far, we have allowed 2 different routes. The first route is with the total distance of 800 meters, and the AV trial is allowed up to 20 kilometers per hour. So this is much more focused on the parking areas, and also the presence of the pedestrian is minimal. For the second route, the total distance is 6.25 kilometers, and the autonomous vehicle speed limit allowed is up to 40 kilometers per hour, and the routes is comprises of intersection, road humps, zebra crossing, traffic light, and under normal condition, the traffic congestion is free flow. Next. So to move forward, we also have strategized the action plan to make sure the continuous expansion and also improvement for e-mobility in Malaysia. Next. The first project is the proof of value concept by localizing the next generation vehicle in Malaysia. So under MARI now, we are developing our own autonomous level 3 technology. We have acquired several LiDAR, and also the onboard computing for the vehicles. This is to make sure that we can perform the our own global positioning system, embed the sensory, safety, control unit, processing, drive unit. So we aim to introduce the low-cost autonomous vehicle in Malaysia to attract more market penetration. Next. So this is the phases of development that we are currently doing. We start with the design of the hardware, electronics, schematics, the fabrication, the firmware development, as well as the communication module hardware interface. So as said now, we have developed our own microcontroller to be embedded into the next generation vehicle as the integrator across the whole hardware, and to make sure that we can deploy the next generation vehicle with the autonomous level 3 functions. Next. Apart from that, we also be working with the Ministry of Transport to expand the mixed traffic routes. Apart from Cyberjaya, we also strategizing to make Putrajaya and Johor for the test field. So for Putrajaya, the routes will be around 2.7 kilometer with the limit of 20 kilometer per hour operation. And also the second route will be 12 kilometer with the 40 kilometer per hour speed limit. For Iskandar Puteri Johor, the route will be around 5 kilometer and 20 kilometer, and also the speed limit will be 20 and 40 kilometer per hour respectively. Next.
Shahrul, you have only 1 minute left. Shahrul, 1 more minute.
Right. Okay, and then under MARI also will be developing the next generation vehicle testbed. So this is to ensure the safety of the validation for safety and also the full function of the next generation vehicles. Next. And we have strategizing so that all the vehicles that have been deployed, the test field that have been established, and also the testing field or the proving ground will be integrated to enable the V2I ecosystem. So the EVIC actually will be able to perform the testing, the vehicle grid interoperability, cybersecurity, and to ensure the safety and also the communication. Next. So lastly, this will be the vehicle to infrastructure ecosystem that have been envisioned under the National Automotive Policy. So with the establishment of V2I ecosystem, we are expecting to formulate better policies and ensure to make sure that the connected ecosystem mobility can be realized by year 2030. So with that, I would like to end my presentation. Thank you very much.
Thank you, Shahrul. So moving on, I have Mr. Jamie Sullivan, Vice President of Business Development North America for DERQ USA Incorporated. Jamie has a Bachelor of Science degree from the Ohio State University and an MBA with a focus on information system. He has spent over 20 years working with governments in multiple roles on software mobile solutions, public sector applications, and wireless infrastructure for public safety, education, and other departments. Jamie has extensive experience working with government and public safety around solutions design and integration using his digital Six Sigma skill. His paper will be on improved traffic operations using safety insights. Over to you, Mr. Jamie.
Great, thank you. Good evening. Are you guys seeing my slide okay?
Yes.
Okay, great. Thank you. So Jamie Sullivan, head up business development for DERQ here in North America. So we're deployed on 3 continents globally, been in business a little over 5 years, and have a core focus on collision avoidance between pedestrians and vehicles. And we've got a lot of intellectual property focused around vulnerable road user intent prediction, as well as sensor fusion. So a little bit about the DERQ platform. Our focus is where we're going to take data from this area where we've got a software platform. We're taking data from detection cameras, CCTV cameras, thermal cameras, radar, starting to mess around with LiDAR a little bit, as well as traffic controller data. We run that through our software platform. Again, we don't manufacture or make any hardware types of solutions in that, but we process that data and then we output it into a couple of different areas focused on so a couple of different buckets around analytics and connected vehicle. On the analytics side, we're looking at things like near misses, wrong way driver, pedestrian safety, your traditional counts, classifications types of events and that. And we process that and output that into a visualization platform for folks to then process that data, build it into reports, and have recall of that data as well. So we process all that data and then store just a 10 or 15 second snippet of what those events are. On the connected vehicle side, we're doing all the offboard perception. So everything that's happening outside of the vehicle, where we can collect that data from, again, new or existing sensors. We don't have any particular care for either. So whatever's there, we'll be able to process and pull that data in. And then basically use that data for all the, the SPAT map, BSM, PSM messaging, anything that's happening regarding the connected vehicle. And as you kind of look at this platform, this basically becomes the core foundation for how you're going to eventually get to a connected vehicle environment. The use of the analytics today help provide safety, planning, operational needs, but also it outlines, what is needed for a severity level, input as to what is a safe intersection in that, and then it obviously sets up for what's required and needed for that connected vehicle environment in the future. So as we look at what it is we do, obviously we're focused on some intellectual property around vulnerable road user intent prediction, safety. We're an open platform, so we'll take and receive data and send it from just about anywhere. Again, we'll work with newer existing sensors, and then our software will run the same, whether it's at the edge, in the cloud, or in a Department of Transportation data center. And we've got a lot of flexibility in how we do that. From an architecture standpoint, so as you look at this from a decentralized architecture, we can deploy an edge unit. We don't make or manufacture that edge unit, but there are some needed requirements around GPU, CPU functionality and hardened environments that an edge unit is required if you're going to do connected vehicle types of applications. And then process that data at the edge, and then store that the interesting events, and then upload those to the cloud, and then any kind of safety messaging and that from a controller or to an RSU is done there at the edge as well. in the centralized environment, that's all basically stored or run inside of a data center from a DOT perspective. That you could do a hybrid of these two in the cloud, and every intersection and every location on highway and freeway can be some different variants of all these. So it's not a one size fits all, but you can actually deploy it in a number of different ways. Lots of different vendors we've worked with, just a sampling of some of the different hardware vendors that we've done projects and pilots with, just to point out that, again, we're not tied to any one particular piece of hardware. So as we kind of look at what we do from a core standpoint, we kind of look at this, how we kind of build up what Dirk does essentially is, as anywhere in the field of view here, we're doing detection and then prediction of those vulnerable road users. So, bounding box green, they're staying off the roadway. Bounding box red, then they're entering into the roadway. And we're doing this anywhere, in the field of view. It's not just in the crosswalk. So as we detect these things that are happening, we could share that data, 10 times per second with a number of different entities, locations, what have you. So whether it's connected vehicle or it's a rapid flashing beacon, there's a lot of different things that we can do with that data. There's also a number of different things we're doing in terms of that prediction and intent. So it's not just looking at head turns and direction and velocity and those kinds of things, but there's actually over a dozen different algorithms we're using to predict that intent. And then our goal from here is obviously adding seconds back into the equation that ultimately we help avoid that collision altogether. So as we look at here, you can see kind of what we're doing on the left screen from an analytics perspective. In terms of the detection of the jaywalker, mid-block, obviously those things kind of get recorded and stored for data purposes. But then on the right, what you're seeing is the transmission of the data, right? So this is the connected vehicle, 10 times per second information that's going out, direction, heading, so on and so forth. So if there are privacy concerns, obviously the video on the left can be purged, metadata on the right can be saved and used for the reporting and the connected vehicle types of applications. So there's lots of different ways to get around that, but this is just a good visualization of everything that's happening from behind the scenes. So as we kind of take it to a larger intersection, you're seeing the detection and prediction of vulnerable road users, classification of vehicles, path history, path prediction on the right from a top view, just seeing how it all kind of comes together. So this is used for both, video detection analytics capabilities. So if there's radar, LiDAR, those kinds of things, we're doing that as well. But the video tends to be kind of an all-encompassing that most applications kind of fall into that. And then on the right, you can see obviously what's happening with the path prediction and those kinds of things. So as we kind of bring it all together, this is a good example of a location where a rapid flashing beacon, the yellow flashers just weren't good enough. And this is Dubai, and they wanted to actually have something a little bit more visible. So there's a single camera that's seeing both sides of the roadway. You'll see at nighttime the triangle was installed to be a more visible warning, so that as it predicts the intent of a pedestrian to cross, it starts to flash, and then as they enter into the roadway, it picks up with intensity. There's also a connected vehicle project here. So there's about 100 or so connected vehicles that are also getting that message at the same time. So this is just a good example of how that messaging sent to both signage as well as connected vehicles could be to a mobile app, etc. As we look at this a little bit further, we could start to provide heat maps around detection of these kinds of incidents, or with near misses. You'll see somebody cross dangerously in this particular one, and as you kind of build these up, you could begin to provide some mapping. We even go a few steps further. There's no real definition of what is a near miss. There's no standard around it, so we provide some advanced filtering that enables us to actually dive down into these events. And really allow end users to define what is a near miss based on time to collision, gap time, severity, post encroachment time, etc. And then end users and DOTs, depending on what part of the world or where you're at, you can define what is a near miss and what you're doing. And we do that with a number of our different solutions that we have, whether it's wrong way driver, jaywalking, illegal U-turns, etc. We provide some advanced filtering that allows end users to really kind of modify what you're seeing, because the artificial intelligence will pick up everything that it's defined to do. some of those events might be benign, some of them might be dangerous, right? So you want to be able to filter through those to really get down to what's really happening at the intersection, crosswalk, or in the roadway. So I'll wrap up on this one. This is a good just sampling of how infrastructure acts as a redundant safety system for autonomous vehicles. A lot of autonomous shuttles have been shut down because of safety concerns, emergency stopping. They only go 10 or 12 miles an hour. Where we get into the situation of those autonomous shuttles having to stop abruptly, even though they're only going 10 or 12 miles an hour, people can still get thrown around inside the shuttle. By the shuttle using the infrastructure as a redundant safety system to the onboard systems, it'll actually come to a more gradual stop. Users have a much more comfortable ride, and it also allows autonomous shuttles to start going faster. So instead of only going 10 or 12 miles an hour, they can start look at going 20, 25 miles an hour and faster. All right, so with that, I will probably wrap up there, and if there's any questions, happy to take some in the time remaining, and happy to share these slides through Janica.
Thank you, Mr. Jamie. It's a very interesting product, and I'm sure you will generate a lot of questions to be asked to you. Okay, our final paper in this session will be presented by Dr. Wizadi binti Hamidun from Malaysian Institute of Road Safety, or MIROS. Dr. Wizadi is a civil engineer, graduated from University Kebangsaan Malaysia, and eventually earned her MSc and PhD degree in transportation and logistics. Her experience focuses on road safety for pedestrian, motorcycle, and public transport. She is currently a senior research officer in MIROS, and she'll be highlighting her experience in her paper, Modeling Pedestrian Crossing Risk at Signalized Intersection. The floor is yours, Dr. Wizadi, for your video presentation.
Good morning, ladies and gentlemen. My name Thank you, Dr. Leong, and thank you to ITS Canada and also ITS Malaysia for organizing this webinar. So, Janet, can you find my video presentation?
Yep, let me go see if this works here. I'm gonna go and use my presentation. Bear with me here for a second.
All right.
Can you see my screen?
Not yet.
Yes.
Yep. Okay. So I'm gonna start the video right now.
This is not my presentation.
This is Rizadi. Can you see it on my screen?
Yeah, but this one is not my presentation.
Sorry. Can you see my screen called Modeling Pedestrian Crossing Risk at Signalized Intersections?
Not yet.
Yeah, I don't see it too. Yeah.
Okay. So Rizadi, do you want me to play the recorded presentation or your PDF format?
The recorded one, because I already timed it. Manage the time.
Can you see it?
Not yet. I can hear the voice, but not the slide.
Yeah, I don't see it too.
Okay. Okay, bear with me for a moment, please.
All right.
You still can't see my screen?
No, I don't see it too.
Yeah.
You can't? Okay. Click start. Okay.
Okay, my topic of presentation today is the modeling pedestrian crossing risk at signalized intersection.
Something is not working here for me. You still can't see my screen?
Not yet.
Yeah.
Okay. Would you be able to do your presentation without the video?
Yeah, but it's only PDF. Yeah. Okay.
Okay, bear with me here. Let me get the.
Okay.
Can you see my screen now?
No.
Yes.
Oh, yes,
Okay.
yes.
Okay.
Okay. Good morning,
This
ladies and
work.
gentlemen. This one is PDF, right, Janet?
Yes. Yeah.
Okay. All right. So good morning and good evening, ladies and gentlemen. The topic of my presentation today is the modeling pedestrian crossing risk at signalized intersection. I am Rizati from Malaysian Institute of Road Safety Research, MIROS, an agency under Ministry of Transport Malaysia. All right. Next slide, please. So let me start by giving some facts related to the global pedestrian crash. Every year, about 1.35 million people died resulted from the road crash, and between 20 to 50 million suffer from non-fatal injury. So out of this 1.35 million road crash victims, more than half of the road deaths are among the vulnerable road user or the VRU, including pedestrians, cyclists, and also motorcyclists. So when we focus on the VRU, especially pedestrian, more than 270,000 pedestrians killed every year, and it constitutes about 22% of the world road crashes death. So talking about pedestrian as a vulnerable road user, they have a higher risk of death per kilometer travel and become a large portion of road victims in low and middle income country. So next slide, please. Next slide, Janet. So as you are aware, road crashes is also a growing concern in Malaysia, where the death due to road crash exceeds 6,000 every year. So we can see from this red line graph, there are no trend of decreasing number. Okay, next slide. So actually with average of 6,000 deaths per year is equivalent to 20 jumbo jet crash per year, or 17 road users die every day in Malaysia. Okay, next slide. For pedestrian crash in Malaysia, the fatality rate of pedestrian is the third highest after motorcyclists and car driver. So this statistic is not much different every year. From the figure here, we can see the declining trend of pedestrian crash over 10 years time from 2008 to 2018. And we can see here we have 400 in recent year in 2018, but it's still a huge amount of losses. In total, we are actually losing 5,684 lives of pedestrian over 10 years, having more than 400 pedestrian deaths in Malaysia. It is equivalent to 1 or 2 pedestrians die every day. Okay, next slide. So although we have a good transport system in Malaysia, where the provision of the road is in accordance to the hierarchical function as required in the established guideline, but still we face some challenges in pedestrian safety, which related to the issue of sharing space with traffic on road, collision with vehicle happen due to various movement and speeding, the pedestrian crossing facility provided on the road sometimes inappropriate and not properly linked and managed. And the most difficult challenge is the issue related to the behavior, such as the pedestrian violation, jaywalking, dash out crossing, which is high in developing country. Issue related to the driver behavior, such as driver disrespect and violation, which is including running red light and also the vehicle stop at crosswalk. Okay, next slide, Janet, please. Now we're turning our attention to the pedestrian crash, especially at signalized intersection. The crash happens when pedestrians meet any vehicle at the same time and the same place. So when a pedestrian meet uh, the vehicle at the same time but different place, or meet at the same place but different time, there is no crash happen. And this crash event is a repetitive event as we have many pedestrian and vehicle on the road. The risk of pedestrian crash at signalized intersection increase 8 times when pedestrians adopt illegal crossing and driver disrespect red indication by traffic light or running the red light. Okay, next please. Okay, so by using modeling tool like PetriNet, the risk of pedestrian crash at signalized intersection can be predicted. Crossing behavior observed during the site observation was extracted to identify the sequence of event in pedestrian crash. Then this event sequence was translated into the graphical model in PetriNet. Okay, so next slide. So let me elaborate further about the PetriNet. So what is it? So this PetriNet is actually a mathematical modeling tool that capable for specification and analysis of complex and real system designed to model behavior and performance of dynamic system. So why PetriNet? So modeling with PetriNet is easier to understand and visualize because it's user-friendly graphical orientation. It is a powerful and flexible modeling tools as we can use it for quantitative and qualitative analysis. It modeling power able to capture many discrete event system, and it based on the solid mathematical basis. It also allows for the abstraction of hierarchical design. So the output from this model is the graphical representation of the pedestrian risk assessment model. The effect of parameter or the factor can be presented in graph, and it will give us the value of the risk after we run the simulation. Okay, next please, Janet. Okay, so this is the basic of the PetriNet. They have a graphical notation named as a place with the circle picture, the transition, the rectangle. Okay, token is a small dot, and also the arch is the arrow. So each notation represents the condition of the agent in the event sequence. So the summary of this notation and the function of this basic notation is given in this table. Okay, next slide. Okay, so the application of the PetriNet is a popular modeling tool in, for example, manufacturing system, the software design, traffic signal control, reliability analysis, process modeling, communication network, and also the rail safety. So next slide, please. Okay, so in developing the model for pedestrian crossing risk at signalized intersection, several steps required as summarized in this methodological framework. Starting with the data collection for the primary and secondary data. Next, we go for the data analysis, and it requires identification of the crossing event, defining zone, identify pedestrian behavior, accident event sequence, and also the risk parameter. So the third stage for the model development, the change event in PetriNet structure was established, and this must comply with the PetriNet properties, otherwise the deadlock condition appear. The model need to be calibrated and validated. Once all steps accomplished, the output is the pedestrian crossing risk assessment model, or I call it as a PETCRA model, which can be used to estimate the risk of crossing risk of pedestrian at signalized intersection in Kuala Lumpur. Actually in the video it's showing you there is a animation showing together, so it show step by step. Okay, okay, that's okay. Next slide, Janet. Okay, this is the site observation for the primary data. Together, I need to compile 8 location of signalized intersection that have experience in high number of crashes within 3 years, and all locations should located near to the pedestrian attraction, such as a shopping complex, transit station, and also the business building. Okay, next slide. So actually the PECRA model was developed in hierarchical structure, consists of 4-layer model as shown in this figure. So on the top model is called risk assessment model. So under this model is the first hierarchy model called as the pedestrian crossing event model. Okay, next. Okay, so this is the model under the first hierarchy model, and under this model, there are 5 submodels that take into account the risk factor to pedestrian crash at signalized intersection, which include the pedestrian characteristic, pedestrian crossing behavior, vehicle characteristic, vehicle passing behavior, and also the road characteristic that called the lane cross submodel. Okay, next. So under each of a submodel in the second hierarchy, there are the third hierarchy model. For example, this hierarchy model that consider the pedestrian factor. Okay, so the blue color, the figure that highlighted in blue color is the third hierarchy model. The figure that showing in highlighted in red color is the second hierarchy model. All right, next, Janet. Okay, similar approach for the submodel that consider the vehicle factor. So the submodel under the second hierarchy model is called vehicle characteristic and also the vehicle passing. So under vehicle characteristic, there are 4 submodel that lead under the third hierarchy model. Okay, next, Janet. Okay, so this is the model that consider the road characteristic factor. I call it as the lane cross model. So under this model, there are 4 sub-model that considered as a third hierarchy model. Okay, next. Next, Janet. Okay, so in summary, there are 13 factors that highlighted in this red box. There are 13 factors considered as parameter in this developed model, which include the signal timing, the volume of the pedestrian and also the traffic, the age and gender of the pedestrian, the number of lane and also the existence of the median, approaching speed of the vehicle, the violation of pedestrian and a vehicle, and also the road surface condition either wet or dry. Okay, so you can see the criteria that considered under all these factors. All right, so next. Okay, so the effect of each factor and parameter in this model was examined using the sensitivity analysis. So this analysis requires 64 simulation run to cover the selected 4 parameters, including the number of lane, the existence of median, approaching speed of vehicle, and the temporal violation of the pedestrian. So overall,
After we study, yeah, only 1 minute left.
Okay, all right. So overall, the risk of crossing pedestrian would be lower when they comply with the signal indication at the low traffic, with low approaching speed at the road with 1 and 2 lane equipped with median. Okay, next. Okay, so the model, the PECRA model developed in this study serves as a tool in assessing the risk of pedestrian at signalized intersection. The data required for the model predict the risk value through simulation can be easily obtained through the site observation. The replication of the methodology can be accomplished even though the accident data is unavailable. The outcome from the PECRA model are expected to help traffic engineer and also the planners from authorized agency to prioritize the risky signalized intersection and identify the potential countermeasure for the pedestrian safety problem. So result drawn from the analysis of this study is expected to provide an understanding of the pedestrian risk in relation to the combination of the risk factor at signalized intersection. So next, could be the last slide. Okay, so for generating the risk of pedestrian at signalized intersection in Kuala Lumpur, data from SCAD can be used, such as the vehicle volume, the number of lane, the green time, so data on the pedestrian volume and behavior and also the vehicle speed can be obtained through the site observation or can be extracted from the CCTV. Additional accident data may be needed for the model validation. So with this, okay, next slide, Janet. Okay, so with this, I end my sharing session. Thank you so much for your kind attention. So over to you, Dr. Leong.
Okay. Thank you very much, Dr. Vizaidi. Your presentation reminded me of my struggling with Petrinex during my PhD days in the university. Thank you, thank you. It's a good memory for me too, yeah. Okay, so I'm sure all of you have a very good listening to all of our respected speakers. And we have 4 people focused on the application of IT technologies for safety aspect, while Shahrulnizam talks about e-mobility. I have a few questions, and because of the time constraint, I may not be able to give you a summary of each paper, and I would like to have the Q&A session on. But before I start the Q&A, I would like to invite Mr. Joe Lam from ITS Canada to join me to co-host this Q&A, as well as do the wrapping up later. For your information, myself and Joe Lam has been associated for more than 30 years. He's really, really my good old friend, and he's still my sifu. Good morning. Hey, good day to you, Joe. Nice to see you here.
Thank you.
So can we start the Q&A session now?
Can we ask all panelists to turn their webcams on, please?
Yeah. Thank you, thank you, thank you. Yeah, a couple of questions. Maybe Joe, are you accessible to the questions there?
No, but not to worry. You know, I'll just watch. And,
okay, then I'll start the questions. Maybe you can help to moderate the questioning and also the answering. So there is a question that is asking. This question could be applicable to the first and the second speaker. He talks about those products that you have, the application in Canada. So the question is whether the equipments or devices that you are using requires Canada's law to get it calibrated. If yes, how long do you need to calibrate all these devices? This is the first question. Maybe you mentioned AI or the other one, Bluecity. Asking whether you need to calibrate. Yeah.
Yeah, so our onboarding process currently has the installation at the intersection, which takes approximately an hour to install. We ask that we have in the installation a 5 to 10 day calibration period, just to make sure that we're classifying and counting all road users accurately. And that's the worst case scenario. So we ask that there's like a 5 to 10 day period But once that period has elapsed, the equipment's good to go.
Okay, thank you. There's another question from the Route Division of Public Works Department. She would like to get your views on how ITS can be utilized in the physical road infrastructure improvements besides the use of AI software, intelligent devices, and mobile equipments like camera, drone, and so on and so on. So this question is a general question. Anybody want to address it? Your opinion on whether ITS can be utilized in the physical road infrastructures improvements.
So I think that, I mean, if you're looking at how it can benefit physical infrastructure improvements, absolutely. So how, traffic behaves, how roadway conditions, changing environments. I mean, that's a big benefit for AI and this technology is understanding situational awareness. And that's, I think, what probably Philip's, focused on. That's what we're focused on. Those kinds of things to understand what's happening in a real-time environment. And as roadways and that change constantly, to be able to provide that constant feedback, and then that could be used from a historical and long-term perspective to understand, volumes and those kinds of things. You need to make roads, wider, et cetera. Do you need off ramps, things like that? So absolutely, it can have impact on the physical infrastructure.
Right. Thank you, Jamie. In fact, I totally agree with you that ITS can be applied even to the existing physical infrastructures to actually indirectly enhance the optimum utilization of our resources using real-time data to analyze rather than use physical improvement, widening without actually limit. So using all these intelligent transport system devices coupled with the latest technologies, AI, big data analytics, it does help to increase the capacity of the existing infrastructures. Thank you. And the other one interesting from our Indonesian colleague. Thank you, ITS Indonesia and all the participants from Indonesia who joined us this morning. And there's a question for Dr. Rizadi. He says that most of the accidents happen in his company were caused by drivers or other drivers. How do we control this risk? Dr. Rizadi? It's the drivers.
Yeah, the driver behavior is the most challenging issue in not only in Indonesia but also in Malaysia. But in Malaysia, we have a road safety education that embedded and start during 2007, and from this we try to educate the school children how to behave and to be more alert for the risky situation and at the road, and how to become more um, uh, we can say you have a control behavior, become a good driver for the future. So I would like to suggest for Indonesian friends, maybe road safety education would be the best solution for this. Although it will took a long time, but it must start somewhere. Thank you.
All right, thank you, Dr. Rizadi. Joe, do you receive any questions that you would like to pose it to our speakers, the panelists?
No, not with me. I think they all go to you.
Okay. Then I have another. Sorry, Jane, you have anything to add?
Yeah, I have a question for presenter number 7 on e-mobility developments in Malaysia, which I thought was an intriguing presentation, like all the other ones. And I was just wondering, it contained a lot of details, and I am just wondering, what is your citizens' engagement in all of this process about e-mobility? How do you ensure that the Malaysian population shares or finds out about all these the details about electric vehicles, e-mobility, etc.?
Could you please repeat the question, because I'm couldn't catch at the end. But one more time.
So during your presentation, your detailed presentation, you talked about electric vehicles and e-mobility. So what is your citizens' engagement in sharing your knowledge and information about e-vehicles to encourage, I guess, the purchase of e-vehicles or e-mobility as with respect to the citizens of Malaysia?
Okay, we have conducted a lot of awareness program, to spread the awareness about the programs by the government to promote the utilization of EV. Apart from that, government also have made official announcement with the reduction of road tax, by 50% for those who are using the EV. So apart from that, of course, all the activities has been published in our website, and then we have conducted the webinars, etc. Apart from that, moving forward, we also will be sort of enhancing the incentive from 50% to the full road tax exemption, upon the Cabinet of Parliament approval within this year. This is just to attract the utilization of EV cut across nationwide, and also to increase the economy of scale, and also the usage for electric vehicles in Malaysia. So apart from that, for those industry that is involved in the development for this ecosystem for electric vehicles, and as well as the autonomous vehicles, we also give you incentive in terms of the corporate tax exemption. So this is how we attracting the more participation, more awareness on how we can deploy the long-term strategy for electromobility, as well as the next generation vehicles in Malaysia.
Thank you very much.
Thank you, thank you, thank you. So there's a question to Bluecity. Please elaborate on the cost efficiency of Bluecity LiDAR system installation compared to other methodologies such as using radar cameras. Is the cost of computing system and other backend support included?
Yeah, so our model includes hardware. So we have a LiDAR sensor and an edge processing unit, and we typically give a 2-year license to the SaaS platform for the visualization tools. So in comparison, for the total cost of ownership of our solution versus other solutions, we're finding that we are highly competitive with other technology solutions out there, primarily because the installation is so minimal. We typically need one sensor at an intersection. We do not have to have one sensor per lane or per lane. And that sensor is typically installed on the same corner or pole as a traffic light controller, so you don't have to run any wires underneath the roads. So we're very competitive against the other technologies out there.
All right. Okay.
Dr.
Yes.
Leong, Dr. Leong,
Yeah.
I found a question from Lauren to Philip, actually, of Bluecity. Basically, what he was asking was that, well, conditions vary from intersection to intersection, and particularly from country to country. So if we're going to apply such a method in Malaysia, how long would it take to train your LiDAR system to local conditions?
Yeah, so to clarify my earlier answer about the 5 to 10 day configuration, that is to make sure the model is working, the algorithm and detection is working all right. From a calibration standpoint, with LiDAR, the benefit is you don't have to do any calibration. Once the LiDAR is set, we're measuring absolute distance from the LiDAR to each individual object, so you don't have to do any calibration. But we do ask for that 5 to 10 day period to make sure that the model is recognizing all the classifications and the counts of all road vehicles, because of exactly what you say, Joe. Every intersection can be slightly different, and as we build up our reservoir of data, the model will get better and better. So for now, we're asking for a 5 to 10 day period to make sure everything is looking okay.
Now, Jamie, may I ask you the same question?
Oh, sure. Yeah. So so I should clarify. We're anything that we deploy from a solution standpoint to jaywalking, wrong way driver, those kinds of things. we start at 95% accuracy. So if we can't get that out of the gate, we don't really call it a product as of yet. And so we're a machine learning solution, so we get better with time. So as we kind of start from that perspective, it could be a few days, it could be up to 2 weeks, depending on I think Philip's kind of outlined a lot of it. It just depends on every intersection is different, every situation is a little bit different. There's no cookie cutter kind of approach to these things. We are working on some standardized ways to deploy, where it is just a matter of hours to a day to get up and running, and then have the system understand what's going on within a day. But we're still a little bit of a ways off from that. But generally, we're inside of 2 weeks and pretty comfortable with that timeline.
Thank you, gentlemen.
Okay, thank you. Actually, there's another question addressed to either Emmanuel or Jamie. The question is, LiDAR and vision-based AI analytics have their own advantages and benefits. Could these two technologies be used in a complementary fashion, or are the analytics from these two technologies non-complementary?
So I'll let Philip answer as well, but from our perspective, absolutely. So we're a software platform that we're predominantly focused on video because it's what's out there the most of, right? So most intersections have cameras or some type of sensor, radar, lidar, or I'm sorry, radar or thermal. We see actually a very promising future for lidar. It's just not readily deployed as much as cameras are. So absolutely, from our perspective, our platform will take all that data.
Okay, thank you. So there's one question for Mr. Shahrul. How does MARI intend to transfer the next generation vehicles technologies developed by you to the vehicle manufacturers? Is this R&D research work being done in collaboration with any specific vehicle manufacturers?
Yes, of course. We're not only working with the specific certain OEMs or vehicle manufacturers. We're also working with our vendors, tier 1 and tier 2. For vendors, we are working together with them to develop the critical components to be embedded to our local vehicles models that is produced by our local manufacturers. So we are work in collaboration with the startup companies, vendors, and also OEMs to make sure the success of this project. So we are not working individually, but as a group.
Okay, thank you very much, Shahrul. Thank you. Sorry.
It's Yannick here. I think Philip also wanted to answer the previous question. Philip, after Jamie, go ahead.
No, I just completely agree with Jamie. LiDAR and AI, like milk and cookies, they're great together.
Joe, do you have any question that you have received?
I do have one question about whether the technologies discussed by Philip and Jamie are affected by weather conditions, and I assume they're not. So I think that's a non-question, really, right? Unless you disagree with me, guys.
Well, it's a loaded question, actually. It's a great boardroom question, but in practice, I don't think it's really material for two reasons. One, the LiDAR solution that we're using is a very particular wavelength, so it's not really affected by weather. So that's from the hardware perspective. From the software perspective, you have to understand when the laser is traveling and hitting an object, we're reading an object like, I don't even know what it is, hundreds of times per second. So even if there's a piece of moisture in one of the frames, we're seeing it 99,000 other times in that second. So yeah, weather is not really a factor.
Okay.
Thank you.
Yeah, and from our perspective, AI can actually clean up, sensor visions, right? So whether it's radar, thermal, video, I'm sure Philip would say the same about LiDAR. That the artificial intelligence can actually clean up what the image that is being brought back. So where it's kind of a standard fallback to kind of point to weaknesses in that, but with where we're at today, the sensors are actually pretty good, and the AI is even better, and that kind of argument is really kind of going away rather quickly.
All right, thank you. Maybe let me pose you the last question. This question is, to me, is a general question. It goes like this: there are occasions when we may want to do forensic analysis on historical pre-recorded video. Can your solutions applicable? Any answers from the two gentlemen?
Yeah, so I think pre-recorded video, is that the question?
Yes,
absolutely. Yeah, so we could take live data, recorded data, near real time. It doesn't matter. So there's lots of different ways for us to deploy and provide analytics on what we're seeing at the intersection. So yes.
Okay, thank you. And there's one more question from Michael Kottos to the organizer. How are the systems demonstrated by Philip and Jamie being used to model traffic and transport improvement? Good question. Does a solution able to model traffic and transport improvements?
Yeah, so we're supplying access to data to the cities and to consultants to crunch the data any way they want. I don't have any insight into any modeling currently, but I can follow up with the technology team to get a better answer on that one. So not my department.
Okay, Jamie, your comments, Jamie?
Yeah, so we don't do any modeling specifically, other than real-time path prediction and history, situational things. But the data can be exported to other platforms that do that, and I would imagine Philips is the same. So, but we just, as a solution, we don't do the modeling piece. That's where the PhD folks kind of take over from the data perspective.
Yeah. Okay, there's a general question asking all the speakers your permission to download your presentation. Is it okay? All right.
Yeah.
Okay. Thank you.
Sure. Absolutely.
There's another question. In view of the negative externality free flow traffic infrastructure has on urban sustainability and livability, how can ITS be leveraged to allow more efficient movement of surface transit and non-motorized transport users rather than cars and motorbikes?
Maybe. Okay, go ahead, Philip.
I'm not sure I got that entirely, but I think as a first step, it's getting better data to analyze is step number one. And with the more and more multimodal capturing technologies such as LiDAR and camera, being able to get more data in will allow to make better decisions and make the network for vulnerable road users safer. So I said getting more multimodal data initially is probably a good start.
I see.
Yeah, just to tag on to that, so I think because of the pandemic and that, I think we're seeing a change of use of roadways, right? So and there's a number of communities that are looking at how does the roadway serve those alternative road users like pedestrians, cyclists, scooters, et cetera, as opposed to the roadways being specifically built for vehicle traffic. And that's when you're going to make those kinds of shifts in the infrastructure and what they're used for, this is where ITS is absolutely critical to make those changes.
All right.
Maybe
okay. Let me. Sorry, Joe.
Maybe I can make a few comments. I guess with the pandemic upon us, we have been innovating. For example, micromobility becomes more popular, such as electric scooters. Wow, in North America, when we say scooter, we mean those skateboards,
Right.
Not the actual scooters on the streets of Malaysia. and e-bikes and so on. But so now we come with the idea of math, and that takes a sharing of data and some application of AI to interpret what the mobility customer wants. For example, the transit companies now are going to demand responsive transit at the extension of the urban area. And again, through AI, they can have a real-time schedule to accommodate customers who just call to get the bus and so on and so forth. So there are ways and means you can do it. And so more and more we are thinking about cross-cutting things and integrating all the technologies together into one smart mobility part so that we can benefit from all of it and not just deal with one mode at a time. So anyway, that's enough of the speech.
All right. Okay. Since time is running short, I will post the last question by Madam V, one of our ITS Malaysia Council member. Her question is, how has the travel behavior pattern brought about by the pandemic affected the deployment of ITS applications using existing infrastructure? Any question from any of the speakers? Any answers?
Could you come again? The first line.
Okay, let me repeat the question. How has the travel behavior pattern brought about by the pandemic affected the deployment of ITS applications using existing infrastructures? It's a very good question because the pandemic changed the way people travel, changed the way people use public transit. Yeah.
I think yesterday, last night I talked about that because the pandemic impact our rush hour is no longer the rush hour because the traffic pattern, the traditional traffic pattern has been disrupted. So really, we need more smarter control methods to deal with it. And I think AI can help us to have smarter methods to detect the change in traffic pattern and to accommodate the different traffic patterns, you know. That's
okay. It. Thank you. Okay, as time is really running short, so I would like to thank all the speakers for your excellent presentation and also the active participation from all our participants who are listening to this webinar. But before I close the session, I would like to pass over the floor to Joe Lam to do the final wrap up. Thank you very much to all the speakers.
Thank you, Dr. Leung. Well, I'm sure you all agree with me. It's been a good webinar over 2 evenings, and I certainly enjoyed it myself, and hope you do. And there's so many people to thank. So first of all, I'd like to thank all the speakers for preparing very good speeches, beautiful slides, and what's really good was they abide by the time allotment, which is good. So thank you very much. And of course, we have the wonderful moderatorship of Dato' Leung today, and yesterday by Mohd, and was well done. And of course, I thank all of you who are participating in this seminar. I also like to thank 3 VIPs, particularly Ryan Beck from our Highway Commission office in KL, and Ian Steele, the chairman of ITS Canada, and also, of course, Dato' Ismail Saleh, my good friend, the president of ITS Malaysia, for honoring us in welcoming us and so on. But of course, all this wouldn't have happened without the organizers, and I'd like to thank organizers on both sides. The idea was actually initiated by Dr. Leung, a few months ago, and now we have organizers from their side, such as Lawrence Liu and KK Chin, and many others. And also on our side, we have the invincible Yannicka, without whom nothing would have happened, you know. So, so I thank you very much. And I think we should all have a round of applause to all the organizers. And, you know, on behalf of ITS Canada, I really love to see our partnership with ITS Malaysia continue and maybe even enhance, pandemic or not. So the webinar is a good example, and we should continue our cooperation. And on behalf of our Canadian ITS Forum, I'd like to say to you that we'd love to do business with you guys, maybe in Malaysia, maybe in Canada, but better still in a third country with partnership between us. So if you need any more information, of course, you can contact the speaker themselves, people like Philip and Jamie and so on. Or you can contact our Yannicka or myself. And if all else fails, you can always talk to Mohd at our Canadian High Commission office, and he would provide you, get you the right information. So, so I thank you, and again, I'd like to thank once again Yannicka, who really worked almost 7/24 to make this happen, and it's not easy, you know. So, and I thank all of you for attending, and I promise you guys, when the pandemic is over, I'll be in KL and having tea correct with some of you in the hawker stand, right? So that's a promise.
Yeah, okay, so, please come, please come.
Yeah, terima kasih, and selamat pagi.
Thank
Okay.
you.
Thank you, Yannicka, before I pass back to you to close the session, can I have anything from our President ITS Malaysia? Oh, can't hear you. Yeah, can't hear you. Can't hear you.
Can you unmute yourself?
Yeah,
He's self-muted. I can't unmute him. Oh, technology. There we go.
Thank you very much. It's all well covered. Very successful webinar. So thank you very much to Yolam and Yannicka, ITS Canada. So we hope the competition will continue. Yeah? So between the businesses people and us and the association. Thank you very much. We hope we will meet again in the next forum. Thank you very much.
Right. Thank you. Thank you. Let's pass it back to Yannicka. Thank you. Thank you.
Thank you. So I just wanted to let everybody know, thank you to Joe Lam for actually, and ITS Malaysia for starting discussions many months ago that we should have a joint webinar. I'm forever grateful for the turnout. Thank you very much, ITS Malaysia, for promoting this event so very much. And Joe, thank you for everything that you do for us. And in particular, all presenters, and you shared your expertise with all of us. I think, you know, as a role of ITS Canada, probably much like ITS Malaysia, we leverage the expertise of our members respectively. And I think last night and tonight again was a perfect example to make that happen. And the webinar recording will be made available on the ITS Canada website tomorrow. But I do encourage everybody to make sure to reach out to all presenters, panelists, if you'd like to learn more about them, what it is that they're offering, whether it's research, because you know, without all of you, we wouldn't be where we are today. And you know, it's all about safety at the end of the day. It's all about a green future for us and for the next generation. So thank you, everybody. Wishing everybody a great day in Malaysia. For those in North America, sleep tight tonight, and look forward to seeing everybody in person at the ITS Canada conference next year, May 4th to May 6th, 2022, in wonderful Windsor, Ontario, if not before.
Right.
Thank
Okay.
you.
Thank you. Thank you.
Bye.
Thank you.
Thank you.
Thank you.
Thank you. Bye.
Bye.
Thank you. Bye bye. Thank you.